Hey everybody, so we have some notes today, and again these notes are on the Pythagorean theorem, and the Pythagorean theorem, it's basically a theorem that only deals with right triangles. Okay, if it's not a right triangle, you can't use the Pythagorean theorem. Okay, so that's important, but anyway, I'm going to read it. It says, in a right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Now that seems like a lot, and to be honest, I'm going to show you something simpler than this in a second, but anyway, that's what the theorem says. Okay, and then again, because it just deals with right triangles, you do need to be able to identify what are the legs and what are the hypotenuse. But real quick, if you notice, here's the right angle. The hypotenuse is always across the right angle, and then the other two sides of the triangle, you could just think of those as legs. And it doesn't matter how the triangle is oriented. Always find, if you want to find the hypotenuse, look for the right angle and then just go across from it, and then that'll be the hypotenuse. And then again, the other two sides are considered legs. They're just called legs. Okay, so that's how we know where the hypotenuse is and where the two legs are. And then here, some people still call this the Pythagorean theorem. I think in the book we have, they call it the Pythagorean equation. It's pretty much this statement using symbols. Okay, if you square the two legs and add them up for a right triangle, it will equal the hypotenuse squared. Okay, so leg squared plus leg squared equals hypotenuse squared. That's what I have here. Maybe if I didn't have the parentheses around it, it would look a little bit nicer. Let me take the... Alright, there you go. So there's no parentheses. You tell me what looks better, with the parentheses or without. But anyway, leg squared plus leg squared equals hypotenuse squared. Maybe you haven't heard that, but I know you've heard this. A squared plus b squared equals c squared. But you have to remember, the hypotenuse is always the c. Okay, in the equation, the hypotenuse is always the c. The legs, they're interchangeable, a and b. So then let's move on. This is the rest of it. This is the converse of the Pythagorean theorem. And remember, in the converse, we switch the hypothesis with the conclusion in the statement. So this one says, if the lengths of the three sides of a triangle satisfy the Pythagorean equation, then the triangle is a right triangle. Okay? And they do have a special name for numbers that satisfy this equation. They're called Pythagorean triples. And one famous triple that comes up that you should know is 3, 4, 5. If I let this equal 3, 4, and 5, it'll be equal. Okay? But this is a famous Pythagorean triple that everybody should really have memorized. Anyway, pause it. Let's move on. So if you look at the examples, I'll give you a second. Pause it, that way you can copy down the first two examples. But if you look at the first two examples, it says use the Pythagorean theorem or equation, whatever you want to call it, to find the missing triangle length. Round your answer to the nearest tenth. This is what I do, or what you should do also. What you should do is identify the hypotenuse, which is C, and then the other two, just call them A and B. If you want, call the smaller one A and then the other one B. Okay? So then I'm going to put it into the equation. Remember, the Pythagorean equation is a squared plus b squared equals c squared. I'm going to plug them into the equation and then solve it. So a is 4, b is 8, c is what we're looking for. So if you square 4, you get 16. If you square 8, you get 64. Then you add those, you get 80. And then right here, a lot of people are not too sure what to do here. To get what right now it's c squared. We want 1c. to get 1c, or to get rid of that square root, you have to square both sides. I'm sorry, to get rid of the square, you have to square root both sides. And then we're left with c equals the square root of 80. And this is why we did that worksheet the other day, because this can be simplified. But I said it will be easier. On this one, we can just type it into the calculator and simplify it, or round to the nearest tenth. So check it out. If I take the square root of 80 and type it in the calculator, I get 8.9. Okay? So thank you, baby Jesus. We don't have to simplify this. We can just type it in the calculator and write 8.9. So your answer is 8.9. So that's the value of C, 8.9, approximately 8.9. And whenever you approximate it, it's always like this. This is the exact answer. This is an approximation. So let me go to B now. Example B. Again, what you should do first, and what I do first, is identify the hypotenuse. Always identify what C is, and then you can say, okay, this one is A, and then this one is B. It really doesn't matter how you put these here, but I always go in order. This one's going to be A, this one, whatever it is going to be B. So B is what we're looking for. So if I plug it into the equation, it'll look like this. 3.9 was A, B is what we're looking for, 11 is C. And then I type it into the calculator, 3.9 squared, that's 1521. 11 squared is 121. Now we want to get this by itself, so we have to subtract this. That goes away. Then we have b squared equals 105.79. And then remember, to get 1b, you have to take the square root of both sides. Then you have, I'm going to scoot it over a little, b equals the square root of 105.79. Type that in the calculator, and when you type it in the calculator, you get 10.3. Okay, 10.3. And again, we're lucky. We can just type these in the we can type these square roots in the calculator, and not do what we were doing the other day. Again, this would be the exact answer. This would be the approximate answer. So pause that if you need to pause it. I'm going to move on. So then on this one, it says determine if each triangle is a right triangle. There should be an A there. Determine if each triangle is a right triangle. Okay. So to do that, we want to use the Pythagorean theorem, and we want to put these numbers in here. Now the only thing on these, definitely put it, you want to go from smallest to biggest. You'll notice C, the hypotenuse is always the largest value. Okay. So if I look at A, I'll say, okay, this one, yeah, A. That one would be A, that one would be B, that one would be C. Smallest to biggest. So then put it into the equation. A is 6, B is 8, C is 9. Start to simplify this. And you don't have to type, you don't have to write everything down. When you're solving these, like you could type this in the calculator, push enter, type that in the calculator and push enter. I'm just kind of showing you every step, that way you realize what's going on. And see how they're not equal? If they're not equal, then it's not a right triangle. It's not a right triangle. Okay? They have to be equal in order for it to be a right triangle. So again, like over here, A is the small one, B is the middle one, C is the big one. Plug it into the Pythagorean theorem. 5 squared plus 12 squared equals 13 squared. 5 squared is 25. 12 squared is 144. 13 squared is 169. 25 plus 144 is 169. So now the two sides are equal, so then it's yes. Yes, it's a right triangle. Okay, and that's it. That's what we'll be doing in today's assignment.